Assalamu alaikum, this is Rizwan from Rhythmatics. So today we will do January 2024 statistics S1 IEL and Excel paper. So moving towards the first question, this is the first question. They're saying here, the histogram below shows the distribution of the heights to the nearest centimeter of 408 plants. Okay, so the frequency is 408. So now you can see here that the diagram here, the histogram is given, and the frequency density is, we have the frequency density here and the heights on the x-axis. So from 5 to 9 the frequency is 32, but this diagram, like this histogram, is representing the frequency density. So you must know the formula for the frequency density. The formula for the frequency density is frequency upon class width. So let us check the first one. The frequency given here is 32. So if we look at here 5 till 9, the height is what will be the height for the frequency density? Well, the scale on the y-axis is not given here. So now from the given data we will try to check the scale, that what kind of scale is there on the y-axis. So the frequency for the first class interval is 32 and the class width is 4. So it means that the frequency density for the first class interval is 8. So, and here we have 4 small boxes. You can see here we have small 4 boxes, 1 2 3 4, and this the frequency density for these small boxes are, like for the first class, is 8, which means that one box is representing 2, which means that this will be 10, then we have 20 here, and so on, 20, then we will have a 30 here. Hold on, let me clear this one. So this is 30, this is 40, this is 50, okay, this is 60. So now we got the scale for the y-axis. Now it is very easy for us to determine this one, and let us check the other one to cross check that whether the scale is correct or not. So you can see here that in the second class, in the second class interval, the frequency for this is 152. Frequency upon the class interval is 4 here. So 152 upon 4 will be 4 3s are 12 and 3 carry 8, 38. So let us check this one, 9 till 13. So 9 till 13 will be, this is 9, 10, 11, 12 and 13. So now we have 4 boxes here, 1 2 3 and 4. So 30 and then 38. So bingo, there you go. So the y-axis scale is, now we got the y-axis scale. Now we'll go for this one, 15 till 17. So 15 till 17, we have on the y-axis we have 3 boxes, which means that this is 30, so 32, 34 and 36. So this is 36. The density is 36. Density is 36, frequency we have to find, and the class width is 2. So by cross multiplication we'll get 72. So this is 72. Okay, so now the last one is very easy, because we have the total frequency. The total frequency here is 408 here mentioned. So now we will subtract, like we have 2 methods. We can either do this one by subtracting all of this from 408, we'll get the result, or we can also go for this one. The frequency density for this is 2 boxes means 4. The frequency density is 4 here, and the class width for this is 8. So 8 4s are 32. So the frequency for this will be 32, and we can also, now after getting this, we will add them to check whether we are getting 408 or not. Just adding them on my calculator. So yes, I'm getting 408. There you go, the first part is done. Now moving towards the second part. For the second part they are asking, let me clear this one. For the second part they are asking to find the use interpolation to estimate the median. Basically this question is from representation of data. So now in the second part we have to find the median by using interpolation. Okay, for this first of all we will make cumulative row here, cumulative frequency. So for the cumulative frequency we have 32 here. Let me add them. 152 plus 32 is 184, and then plus 120 is 304, then plus 72 is 376, and then 408. So now they're asking for the median. Let us first calculate the median, that where it lies, and then we will use the interpolation method. So the median, the total is 408. So we will just divide this 408 by 2, and 408 is the frequency. So by dividing frequency by 2, the cumulative frequency by 2, we get a frequency. So now we have to look that in which class interval this frequency lies. So this class frequency lies here, like you can see, till here we have 184, but by adding 120 we get 304, which means that this 204 lies here in this class interval. In this class interval this frequency lies. So now for this class interval the lower limit is this 13, and the upper limit for this class is 15, and in between we have Q2. So this class intervals in if you look at the cumulative frequency, so this class interval starts from here. This is the 184. By adding 1 in it we will enter to this class interval. So this is the starting point. We'll consider this as a starting point here. 184 is in terms of cumulative frequency, and 304 is the limit. You can see here, because we have 13 here, so following this we will put it here. Okay, so with this 15 I have this, so I'll put it here. Okay, so now going to the formula of the interpolation. So how now we will use the interpolation method. So it's like this. So the starting point here 13 plus, I will take the difference, because this 204, this is the center, so this 204 lies here somewhere, this will be the center. So now I will use it here, 204 minus 184 upon 120. So what is 120? 120 is the difference of these two into the difference of this 15 minus equals to Q2. So now we have here 13 plus 0.333. So by adding them I got this. So this is the answer. So the median will lie on here is 3.3. So this is it for the second part. Now moving towards the next one. So in the next part they are saying that the mean height, this is the next one. The mean height of these plants is 13.2 correct to 1 decimal. Describe the skew of this data. Give a reason for your answer. So you can see that we just calculated the median. The median is 13.3, and the mean they are saying is 13.2. So they are almost equal. So when mean is equal to the median, it suggests that the data is symmetric, not skewed. So skewness typically occurs when the mean and median are not equal, indicating an asymmetry in the distribution of data. So this is for the third part. Now moving towards the last part of the question. Now, two of these plants are chosen at random. Estimate the probability that both of their heights are between 8 centimeter and 14 centimeter. Okay, so if we look at here at the graph, so from 8, 5, 6, 7 and 8, from 8 till 14. So 14 will be here. Yeah. So we will just find the frequencies, and then we will add up the frequencies and then we will go for the probability. So the frequency for this portion it's quite clear. It's 152. It's 152 here. Let me erase this one. Okay, so this is very clear from 9 till 13. Okay, so now moving towards this one. Now you can see here I have to it's from 8. They're asking from 8 till 14, which means that now I have to calculate. This is 8. Now I will consider this class. This is the class now, 8 till 9. So the class width for this one, according to the frequency density formula, the frequency density for this is 8. This is 8, which we calculated. This axis, we calculated this axis in the first part. So the frequency density is 8, and the frequency which we have to find here is a question mark on it, and the class width is 1. So now the frequency for this portion is 8. Now moving toward this one, the last portion, this portion now the class width here is, you can see the class width is 1. Class width is 1. The frequency which we have to find, and the height, the frequency density is 60. So there you go. So now the frequency from 8 till 14 is 150. 2 plus 8 plus 60 becomes 220, and the total sample with us is 408. So according to the probability, the total numbers, they are saying that we have to choose 2 plants. So out of 220 upon 408 into 1 plant is chosen, then the remaining plants will be 219 upon 407. Putting this in the calculator, I'm getting 402 this into 219 upon 407. Sorry, 407. I'm just solving it with my calculator. So I got 0.2901. There you go. So this was the first question is done. Now we will move towards the next question. So in second question, the average minimum monthly temperature X degrees Fahrenheit. This is the average minimum monthly temperature, and it's in X degrees Fahrenheit. And this is the average minimum, and the next one is, they are saying the average maximum monthly temperature Y. So the average minimum monthly, they have denoted this by X, and the average maximum, they have denoted this by Y. So the first part is, in the first part they are asking for the average minimum, for the mean of the average minimum. So it's very easy. The formula for the mean is sum, which is 862 upon the total months, 12 here. So the answer is 71.8. Now in the second part, they are asking, the first part was very easy. So in the second part, they are asking, show that the standard deviation of 12 values of the average minimum monthly temperature is this. We have to show this, we have to prove this, and these are the 3 significant numbers. Okay, so we have to show this. So now, what is the formula for the standard deviation? Remember, they are asking for the average minimum, which means we have to choose the X values from here. Okay, so for the standard deviation, the formula will be x square, summation of x square upon the total months. So the total months we have here are 12. Okay, let me just put the values here. So the values are 62802 upon, it's a straightforward one because here you need to with the formula, and when you have the formula in mind, then it's not like the question is not that much difficult. So, and here we will put the mean. So the mean which we just calculated, the mean, which was 71.8. Let me write it again, and then taking the square of it. So the form, now by putting this, let me calculate this by putting this in the calculator. By putting this in the calculator, I got 8.572. Now they asked for the three significant numbers, so we will pick this one. So 8.57 is the answer, and this one was also a pretty straightforward, like I just put the values in the formula and I got the answer. So in the next part, they are asking calculate the product moment correlation coefficient between x and y. So the formula for this is r equals to sxy upon root syy into sxx. So we have this like here we have this, but this is like this is missing. So now we have to find this one first, ssx. Sorry. So the formula for this will be, and it's also there, it's in your books, summation of x square minus summation of x taking square of it upon n. So summation of x square, we already have it, 62802 minus taking the square of 862 upon 12. Clear understanding of the formulas is must here. You must know which formula you have to use where. So I'm just putting this in the calculator, and I got 881.7. So now I'll just put it here in this formula to find the correlation coefficient. So sxy according to the question is 512.67 upon root syy. In the question they already given, they gave this, and into we will also give this to two significant numbers, two decimal numbers, because already they are dealing with this two decimal numbers. So 881.66. Okay, so now by putting this in the calculator, I got 0.8489. I hope this part is clear now. Now moving towards the next part, important thing so far which we learned here is you must know which formula you have to use where. This is the very important thing here while doing these questions. If you know the formulas, this question will be a piece of cake for you. Now moving towards the next one, for comparative purposes with the UK city, it was necessary to convert the temperature from a degree Fahrenheit to degree Celsius. The formula used was this. This is the formula. Now where F is the temperature in Fahrenheit and C is the temperature in degree centigrade, use this formula and the values from part A to calculate in degree centigrade the mean and the standard deviation. So they're asking for the mean and for the standard deviation of 12 values of the average minimum monthly temperature in Kolkata, given your answer to three significant figures. Given that, now hold on, okay, fine, it's for the next one. So now we have to solve this one, mean and the standard deviation, from the minimum monthly temperature. Now by putting the mean here, they also, like, this is the formula for conversion from Fahrenheit to degree centigrade, or from degree centigrade to Fahrenheit. So now, by putting the mean here, the mean which we got in the first part was 71 point, I guess it was 71.8. okay, fine. So by putting the mean here, we will get the mean for the degree centigrade. By putting the mean of Fahrenheit in the formula, we will get the mean for the degree centigrade. Very obvious, because we are just converting it. So by putting any number, we will just get the converted form of it to the other unit. So we just like the mean of the Fahrenheit was 71.8, which was calculated in the first part. Now we're putting it here. We just like in this formula, by which we will which serves as a conversion. So we will get the mean in centigrade. So now I'm putting it here, 71.8 minus 32. So by putting this in the calculator, I got 22.11. So now going for the standard deviation now. Besides this, there is a concept. Whenever there is a changing, like whenever we change the data, like whenever there is a transformation takes place, like we have transformed this data from centigrade to Fahrenheit, or from Fahrenheit to centigrade, like this is the formula. So whenever we do the transformation, mean is affected. So the mean will be affected. That's why I just placed the mean here. But in case of the standard deviation, there will be it won't affect it. So we will just place the standard deviation here, which was 8.51 in the first part. So the answer will be for this 4.76. I hope the concept is clear here. In the transformation, like this is the answer for the part C. 3 significant figures. In 3 significant figures, we have the answer 4.76. So basically the concept is, I'm again telling you, whenever we are doing the transformation, in the mean there will be no change. Sorry, in the mean there will be change by the amount which they have mentioned. Like here they have mentioned this one, minus 32. So in standard deviation, this whole will be replaced, and this will not be replaced, because 5/9 is not replaced when using the standard deviation, because it's a constant multiplier in the linear transformation formula. Okay, so I think the concept is clear now. Now we will move towards the next part. The next part they're talking about, hold on, sorry, this one is done, part C is done. Now we are doing the next part, part D. Given that U is equivalent temperature in degree centigrade of X and V is the equivalent temperature in degree centigrade of Y, state giving a reason the product moment correlation coefficient between U and V. Now we know this, that the correlation coefficient was 0.8489. So basically the correlation coefficient R is not affected by the method used for linear transformations or coding. It remains the same regardless of how the calculations are performed. So I think this explanation is enough for the last part. So now we are done with the 2 questions. Now moving towards the next question, the third one. Hold on. Yeah. Okay, so this is the third question. So now here they are saying that in a 6th form college, each student in year 12 and year 13 is either left-handed or right-handed. The partially completed tree diagram where P is the probability gives information about these students. Now the concept behind the probability is like, whatever the probabilities you have here will make 1, and whatever the probabilities here will make 1, and whatever the probabilities here will make 1. Okay, so now here the answer is 1 minus P, and this will be like, we have 1/8 here, so this will be 7/8, and this will be 9/10. So this was pretty straightforward. Now moving towards like this one is the first part is done. Now moving towards the second part, they are saying the probability that a student is left-handed is 0.11. Now they are saying, they are like they're talking about the student who are left-handed. So the left-handed, we have the left-handed here and here. Now they, regardless of the year, like they are not talking about the grade, they are talking about the left one. So the left one we have here is this one, and sorry, this one, which means p into 1 upon 8 plus the other one is 1 minus p into 1 upon 10, this and this, equals to 0.11. This will become p upon 8 plus 1 upon 10 minus p upon 10 equals to 0.11. So now solve this one. P upon 8 minus p upon 10 equals to 0.11 minus 0.1. This will turn to 0.1. Now taking the LCM, we have here 10p minus 8p upon 80 equals to 0.01 times 80, and 2, we have 2p here. So p equals to, I'm multiplying this in my calculator, 0.01, and then divide by this by 2. So 0.4 is the answer. Fraction error, it will be 2 upon 5. Okay, so now this was the first part, the second part in fact. So we got the value for p, which is 0.4. So 0.4, we have 0.4 here, and this will be 0.6. Now doing the third part, now find the probability part. In part C they are saying find the probability that the student selected at random is in year 12 and left-handed. Okay, now the student selected as left-handed and he is in, like, the student is in grade year 12. So now this is year 12 and there you go, it's left-handed. So this will be 0.4 times 1 upon 8, which will give us, like, if I convert this into 4 upon 5 into 1 upon 8, this will turn this into 1 upon 20. So 1 upon 20 is the answer for the third part. Now the last part, in the last part they're saying this is done. The answer for the third part is 1 upon 20. It was a straightforward question. They asked for the left-handed students from year 12, so like it was a straightforward question. So now moving towards the last part. The last part is given that the student is right-handed and find the probability that the student is in year 12. Now this question is from the conditional probability. Like one thing, they gave you this thing, that the student is right-handed. So according to the conditional probability, what we will do, conditional probability, now year 12 is, this is year 12, the right-handed is given here, the right-handed is given. So in the conditional probability, the probability which is given, we write it in the denominator, and the intersection part, we write the intersection part in the numerator. So now we'll pick the right hand. You know that the left-hand students are, the probability for the left-hand students is 0.11. So this right hand, like they are in the conditional probability, the right hand, they're asking for the right hand from the whole scenario, like all the students with the right hand. So all the students with the right hand, I will place them in the denominator. So the probability will be, for the left hand student, the probability is 0.11. So I will subtract this 0.11 from 1, and the remaining will be, like, the total probability is 1, so that's why I'm subtracting the 0.11 from the total. So the remaining will be the probability for the students with the right hand. So now for the right hand students in year 12, now the intersection between them. So the right hand students, These are the right hand student. Sorry, this is grade 12, and the right this is the probability for the right hand student. So now we'll just multiply them. 4 upon 5 into 7 upon 8. There you go. So the answer for this will be 35 upon 89. 35 upon 89, sorry. And if I just calculate this, hold on, like if you want the answer in the decimals, I think I did a mistake here, sorry. This is sorry, I think I did a mistake here. This is, I think, in the previous, also in the previous part. Okay, so this is 2 upon 5, and here this is also 2 upon 5. Okay, fine. In the calculator I'm doing the correct calculation, and here I wrote the wrong number. So this is, the answer here is 0.393. Hope the concept is clear. The concept is clear. So now this is like we are done with the 3 questions. Now moving towards the next one. Okay, so now this is the second question, sorry, the fourth question. And in this fourth question, they gave us the marks, the frequency, the French marks and Spanish marks. Like if I read the question, it's a French test and a Spanish test were sat by 11 students. The table below shows their marks. So like we have a table in which 11 students sat for French and Spanish, and the marks are marked here. So the students are from A, they are categorized by the alphabets from A till K. So then they are saying that Greg says that if these points were plotted on a scatter diagram, then the point 30, 90 would be an outlier, because 90 is an outlier for the Spanish marks. Okay, so now an outlier, now they give the definition here of the outlier. An outlier is defined as a value that is greater than Q3. Q3 is the upper quartile. So Q3 times Q3 plus 1.5 times Q3 minus Q1. So Q1 is the lower quartile. So for upper and lower quartiles, like in the first part, they're talking about the Spanish marks. So the Spanish marks are here. So first of all, we will arrange the Spanish marks in ascending order. So now I'm arranging the marks in ascending order: 16, 24, 28, 32, 36, 38, 44, 48, 48, 68, and 90. So now we will find the upper quartile and the lower quartile. So the formula for the upper quartile is n plus 1 upon 4, and then multiply by 3. So 3 upon 4 times n plus 1. So n is 11 here, and n plus 1 is 12. 4 3 is 9. So the 9th term is the upper quartile. So the 9th term is first, second, third, fourth, fifth, sixth, 7th, 8th, and 9th. So the upper quartile Q3 is 48 here. Now the lower quartile is 1 upon 4 n plus 1, which means this will be 3. So the third term is 28. So the lower quartile is 28. Now we'll put this in the formula which they gave in the question. So now greater than Q3 is 48 plus 1.5 times Q3, 48 minus 28. So by solving by putting this in the calculator, we are getting 78. Now the other one, 48 minus 1.5 times 48 minus 28. So the answer is 18 here. We have this The range, we have the range 18 till 78. So now they are talking about the 90. They are talking about the number 90. Here is the, like, the number is here. Hold on. This is, they are talking about this 90. 90 is an outlier for the Spanish marks. Okay, so now in part A, show that 90 is an outlier. Yes, 90 is an outlier because this is the range, and according to the statement here is the outlier is defined as it will be greater than this 78, like the formula which they gave us, q3 plus. So we got 78 by this. So it's greater than, they are saying here, they define the outlier as like it must be greater than, if it's an outlier, then it will be greater than the 78. Yeah, yes, 90 is greater than 78, so it is an outlier. Now going towards the next part, in second part, they are saying, ignoring the point 3090, Greg calculated the following summary statistics. Summation of f is 422 and summation of s is 388, and so on, the data which they gave here. Now what we have to do here, use these summary statistics to show that the equation of the least squares, the regression line of s on f for the remaining 10 students is. Let me write the standard equation. The standard equation is y equals to a plus bx. This is the standard equation. Basically it resembles to this one. Okay, now how we will solve this one? So from here, if I check this is basically the slope b. So how I will find this? B equals to sf s upon sff, means 1735.6 upon 1667 point this. So by dividing this, let me put this in the calculator. Okay, by putting this in the calculator, I got 1.04. Now this one is done. This is done now. Now calculating the value of this a, which is the y-intercept. So the formula for this is, which you have learned in the book. So the formula for a is, like, this is the y-intercept. So this will be mean of s minus b, which is a slope, with the mean of f. So the mean, as like we have 10 students here, so the mean of s will be summation of s, which is 382 upon 10, minus the value for b, which, like, it's the slope which we just calculated, and then the summation of this f will be 422. Like, we have to calculate the mean, sorry, the calculation, the mean of f will be this. So 38.2 minus 1.04 times 42.2. Let me erase this one. 42.2. Okay, so the value for this is the value for a. This calculation for the value of a, and this is the formula which is in your textbooks. So now, by putting this in the calculator, the answer which we have here is this one. So now we will put this here, the values for, this is the standard equation, equals to the value for a is minus 5.72 plus the value for b is 1 point. In fact, it's yeah, the variable is f here. Okay, so this value is 1.05, 1.04, and the variable x, I have wrote the variable x here, but we have variable f, so it's like this. Okay, and here this will be s. So I think it's clear. This part is clear now. Now moving towards the next part, the third part. In the third part, they are discussing in the third part they're discussing that give an interpretation of the gradient of the regression line. It's very simple. You can see the gradient is positive. So basically, for every extra mark in French, Spanish goes up by this gradient. So a positive gradient indicates the positive correlation between the two variables. In this case, since the gradient is positive plus 1.04, it means that as the value of the French student marks increase, the values of the Spanish students marks also tend to increase. So if a French student scores one additional mark, the model suggests that the Spanish students on average would score 1.04 more marks. So now moving towards the next part D. Using the equation they are saying here, two further students sat in French test but missed the Spanish test. Using the equation given in part B, estimate a Spanish mark for the student who scored 55 marks in their their French test. So simply we will use the equation. They already said that we have to use the equation. So the equation is Spanish equals to minus 5.72 plus the gradient times the French. So the French test marks is 55 here, so I'll put it here. Simply putting it here, we will get the answer. Now moving toward the next part. In the next part they are asking a Spanish mark for the student who scored 18 marks in the French test. So which means that we will just put the value of the French test here. I'm putting it here. This is the answer. Okay, so now the last part, state giving a reason which of the two estimates found in part D would be the more reliable estimate. Okay, so now you can see here that the reason we have to give here. So the first reason is about the Spanish. You can see that it starts from 16 and it ends on 90. So this like this 51.58 lies within the range, but 13 is not in the range. So this is the one of the reason like why this is more reliable, because this is within the range. And the second thing is like this is more closer to the mean. This 51.48 is more closer to the mean. Means like by putting this 55 here, I got this one. So this is basically 55 is more closer to the mean. 51.48. And then you can see that as this 51.58 lies within the range of the Spanish marks, so this is an interpolation, and this is outside the range, so this is extrapolation. So now like we are done with this question. I hope it's clear. So question number 5, we are here on question number 5. In the question number 5, they're talking about the distance an athlete can throw a discus is normally distributed. So the question is from normal distribution with a mean of 40 meters and a standard deviation of 4. Using standardization, show that the probability that the athlete throws the discus less than 38.8 meters is this. Like we have to show the probability like less than. So now as per the diagram, like if I sketch it, this is the mean, and they are saying that we have to show that the probability less than 38 will be here somewhere, 38.8 will be here, and they're saying that the probability less than this is 0.3821. Now we have to show this. Okay, which means that if I go for which means that if I calculate, this is the mean, if I calculate this whole portion and then if I also calculate this one, I'm just checking the possibilities like how I will get the answer, the required thing. Now if I subtract both of them, then I can get this one. And besides this, like you know that this bell-shaped curve is like a symmetrical, it's giving a symmetrical view. So if this is 38.8, So here I will also have the same, like the area on both sides will be same, which means that if I get this portion, this whole portion, and I subtract this portion from 1, then I will get this one. So this seems to be like I think this is the easiest way. If like for the above one, I have like this portion is a bit complicated, this portion is a bit complicated, that this one is easy and then this is a bit complicated. So I will opt this version, try to solve it by this way. So for this one, let us first go for the z-score. So I need to find the z-score here. So the z-score will be like what they are asking here. This is the population, so x less than 38.8 they are asking for, which will be equal to, in terms of z-square, let us first calculate the z-score. Z 38.8 minus 40 upon the standard deviation, which is 4. So z is less than minus 0.3. So this portion is like this reading is representing for z-score, this is minus 0.3, and this like this is, as this is a symmetrical, this like this bell curve shape gives us a symmetrical view, so this portion will be a positive 0.3. So now let us calculate this from the calculator. I have the z-score with me, so now shift, like pressing the menu, then pressing the 6th, and then the first one, and then AC, then option, and then below the 4th one, the 1, so 0.3, there you go, and I have it 0.6179. 0.6179 is the area. So if we look at the diagram, 0.6179 means like it's more than a half. So if it's more than a half, so that means that this whole portion is, this area is representing this whole portion, this area, because it is more than a half. So what we will do, this is equal to 1 minus, if I write it like this, z minus 0 less than 0.3, this will be 1 minus 0.6179. so the answer is 0.3821. Fine, I hope this is clear now. Now moving to this next part. In the next part they are saying, hold on, let me clear this one. Now in the second part they are saying that this athlete enters the discus competition. To qualify for the final, they have 3 attempts to throw the discus a distance of more than 38.8 meters. Once they qualify, they do not use any of their remaining attempts, given that they qualify for the final and their throw are independent. So basically what we found in the first part was the probability that the athlete throws the discus less than 38. So this was the success for less than 38.8, but now they are asking for the successes, like if they throw more than this, then they will get a success, like they will qualify. So they have 3, in actual they have 3 attempts. So let's suppose if I say that on all of the 3 attempts, like I will take the view of the failure of all 3 attempts, so it will look like this then. And then the total probability is, you know that the total probability is 1. So I will minus this from the total probability, and then I will get the probability of the success, which means that he will qualify. I will get the probability by which he can qualify. So what they have asked here, find the probability that this athlete qualified for the final. So I just by doing this I got the probability of qualification, so which will be 0.9442. Now this question is basically, now on the second, like this is the first thing which they asked for, find the probability that this athlete qualified for the final on their second throw. Like we have two things here, like if I go through the question from here, given that they qualify for the final. Now given that they qualify for the final, this is the probability for the qualification, and then they are asking for the probability that this athlete qualified for the final on the second attempt, on the second throw. Now this question now is from the condition probability, and in the condition probability what we do, the thing which they are asking, they gave us one thing, given that this given that they qualify for the final, now this is given, so we will put that thing in the denominator, and the intersection between the qualification and second attempt will put it in the numerator. But they are also saying that find the probability that this athlete qualified for the final on their second throw with a distance of more than 44 meters. Now we have to find this, that on the second throw, like the distance of more than 44 meter was made or achieved. Okay, which means in the numerator we have to put two things, the success into the second attempt probability, like the second attempt, the probability of achieving a distance of more than 44 meters. So now here I will make again this bell-shaped curve, and this is the 44 meters, this is the sorry the median is the mean is, what's the mean in the question? The mean was 40 meters. 40 meters was the mean. 40 meters was the mean, and they are asking here more than the throw of more than 44 meters. So which means that they are asking for this area, which means that like it's symmetrical. We will take the symmetrical view. So first of all, this is, they are asking for this greater than 44, so we will find the z-score for this one. So for the z-score, like if I write it like this, no, well, hold on, just a minute, hold on. First of all, I will go for the z-score. The z-score is z greater than 44 minus 40 upon the standard deviation. What is the standard deviation? The standard deviation is 4. So this will be z greater than 1, which means that this portion will be -1, and this one will be, for the z-score, this will be 1. So I can get this one by this z less than 1, and then subtracted from the probability, the total probability. Like by getting this one, the whole portion is 1, and if the less portion, I get the less portion and subtract it from the 1, then I will get this one. So now less than 1, going back to the calculator, I have the z-score with me, so I'll put it here 1, so it's 0.8413. It's 0.8413. So by subtracting it, I will get 0.1587. Now this is the probability of scoring greater than 44 is 0.1587. Now we have a concept involved here. Now you can see that if I make a diagram here, the bell-shaped curve, this portion is, let's suppose this is 38.8 and this is 44. So the area here is 0.1587. And if I goes if I take the z-score. So z-score for this was 0.3, and z-score for this is 1. And the z-score, if I go symmetrically, take the symmetrical value, so this is the z-score now, and this is the mean. So now if I look at here, symmetrically, if I take the view symmetrically, so this is for the 0.3 and this is also for the 0.3, and this one is for 0.1587. So basically what we do in the conditional probability, there is an intersection between the two events which they are talking about in conditional probability. So here the probability of more than 44 is 1.587, and the probability of this portion is 0.3821. so this is also 0.3821. so basically this 0.1587 lies here with this. So what we will do, we will multiply this by 0.3281. so that's how we will get the answer then, and the answer will be, let me calculate this, 0.06422 is the answer. Okay, I hope this is clear. And as this question is from the conditional probability, so you have to write it like this: x greater than 44 on second attempt, keeping in view the given thing is the qualification. This is the given thing, okay, which we put in the denominator. Okay, so now this question is also done. Question number 5 is done. Now we will move towards the next one. So the next question is, now this is the next question. Now here they are talking about, like, they just gave these probability of A is X, probability of B is Y, probability of A union B is 0.65, and probability of B said that A, like, this is the conditional probability and this is 0.3. Now we have to show this equation, we have to prove this equation. So now we'll pick this condition probability, and how we can write this, I told you this thing before, that we will take the intersection, hold on, we will take the intersection, and this one is given, so we'll put the given in the denominator. Now this is 0.3 and B intersection A is unknown, and probability of A is given, which is X, it's in the question. So now probability of B intersection A is 0.3x. Now this thing is unknown. Now we will find this thing, like we have x is also x is unknown, so like we will go for the B intersection A. So now you must be familiar with the formula. This is the formula, plus this B plus A intersection, sorry, to subtract this, A intersection B. So this, it's the same thing, either we write it like this or this, like both are same things. So now you can see in the question A intersection B, A union B is given. So A union B is given, so A union B is 0.65, and probability of A is also given, it's X, and B is also given, it's Y, and A intersection B, we just found out this A intersection B, which is 0.3x. So we have here, this is 1x and this is 0.3x, so by subtracting them we will get 0.7x. Now we have this equation. Now we will remove the decimals. This will become 65 upon 100 equals to 7 upon 10 plus y. Multiplying the whole equation by 100, we will get 65 equals to 70x plus 100y. Now we will divide everything by 5 as a common. 1s, 3s, 1s, 5 1s, 5 4s, and 5 20s. So there you go. So this is the first part. The first part is done, and I hope it's clear. Now moving towards the next part. Okay. So the next part is they are saying that even B and C are mutually exclusive, and such that probability of B union C is 0.85 and probability of C is 1/2x plus y. Find a second equation in x and y. So like we know, we just did this in the first part, that by expanding this one we will get probability of B plus probability of C, and then minus probability of B intersection C. As this is mutually exclusive, like the events are mutually exclusive, so we will put 0 here, and probability of B is y, and this one is 1/2x plus y, and this is 0.85. It's a pretty straightforward question. 0.85 is here. We have, now they're saying and find the second. So this is the second equation. They're asking for the second equation. So this is the second equation which we have. Now they are saying that we have to find the values for x and y. Okay, so we have two equations. This was the first one, and this is the second one. Now we will solve them simultaneously. I think now this is easy. So 13 equals to 14x plus 20y. Okay, so I'll make the subject from the first one, and this will look like this. Okay, instead of going into the complication, I will just use the elimination method. So by elimination method, I will multiply this one by minus 10. So multiplying this by minus 10, the first equation will become minus 8.5 minus 5x and minus 20y, cancel down, and 9x, sorry 14 minus 5 is, yeah, okay, sorry, yeah, 9x, and then I have 13 minus 8.5, which is 4.5. Moving this 9 to the other side, so 4.5 upon 9 equals to x will give me 1 upon 4.5 divided by 9 will give me 1 upon 2. So 0.5 is the answer. Now putting this in the equation, in any of the equation, let's suppose I'm putting, hold on, in this equation, 13 equals to 14x plus 2y. So putting it here, 14 times 0.5 plus 2y, so 13 equals to 7 plus 2y, and 13 minus 7 upon 2 will give me, hold on, I think I did a mistake, hold on, this is 20y, sorry, this is 20y, okay, this is 20y, so this is 20y, that is just, rest is fine. So now this will be 13 minus 7 is 6 upon 20 is 0.3. There you go. So this is the answer. Now moving towards the last part of the question. The last part of the question is determine whether or not A and B are statistically independent. Okay, let me clear this. So for this, like if they ask for the statistically like independent thing, mutually exclusive was discussed before. In mutually exclusive, the intersection will give you 0. So now the mutually independent, in this what we do, they are talking about A and B. So if the probabilities are equal, then they are independent. So the probability of A intersection B is 0.3x, and we know the value of x, which is 0.5, so this is 0.15. And probability of A is x and the probability of B is y, so probabilities are 0.15, so they are equal. So they are statistically independent. Okay, both are equal. So that's it for the 6th question. So on this question, this is the next question, question number 7. So here in the first part, you can see that they are asking for the value of k. They are asking for the value of k, and besides this, we this basically row is for the cumulative distribution. They are asking for the like they gave us the cumulative distribution here, and in this we have an unknown, which is k, and we have to find, and we have to show that the value of this k is 4. So in cumulative distribution, you know that this the last one is equal to 1, because it's like here in this we add up the probabilities, and after adding up the probabilities, we will like the total of the probability will be here in the last cell, and the total of the probability is 1. So the last cell will be equal to 1, and now we will do the cross multiplication, like 8 will go to this side, so 8 minus 4 equals to 4, so k is 4. So like this is done, the first part is done. Now moving to the next part, but before going to the next part, we have to like the value, we got the value for k, and now we'll put the value here, and by putting the value here we'll get the cumulative frequencies. So 1/13 here, 1/13, and then this is by putting 4 here, like 4 into is 8, and 8 minus 1 is 7/26, and then here 4 plus 1 is 5, 5 into 3 is 15, so this will be 15/26. And now here the last one, 4 plus 4 is 8, and like I told you, in the last we'll get 1. So now from this is the cumulative, these are the cumulative distribution values. Now from this, we will solve it to get the values for the probabilities. So the probabilities of x equals to x, so the first one will be same, and now what we will do, we have to just subtract them to get the next value. So by subtracting 7/26 from minus from 1/13, this will be 5/26. So the 5/26 is here. Now subtracting 15/26 from 7/26, we will get 7 and 8, 8/26, which will result in 4/13. So this one is 4/13. The probability is 4/13 for this. Now for the last one, subtracting 1 minus 15/26, we will get 11/26. So this is 11/26. Okay, fine. So this is the probability distribution table. I got the probabilities here. So now for the second one, what they are saying, they are asking for find the probability distribution table. Yeah, I got the table. Yeah, this is the probability distribution row. The whole table is for the probability distribution. Now in the third part, they're saying using your answer to part B, write down the mod of x. So the mod of x means the highest probability. The highest probability will be the value in front of the highest probability will be the mod. Like besides this probability, you have learned this, that the mode means the highest frequency. So the highest frequency, now here the highest probability will be the mod. So in front of highest probability, the value will be the mod. Okay, so now what is the highest frequency? Highest probability. So you can do it by like converting, like putting these values, putting these probabilities in the calculator and check the decimal number. The highest decimal number will be the highest probability. So the highest, like by putting all of them, like I just put the values, I have put the values and I got the highest value for this one. This is the highest probability. So in front of the highest probability, I have this number. So this is the mod. Okay, so now coming to the last portion, the last part, in the last part they are asking for the variance, and you have learned this. When you have this sort of situation, the formula for this will be 13. You have 13 here. I have explained this in the topicals, so you have to remember this formula: 13 square into variance of x. This is the formula. So for this we need to find the variance. For the variance we have to calculate, like, what is the formula for the variance? The formula for the variance is minus expected mean. This is the formula for the variance, expected value and minus this one. Okay, so now we will do the working here. For the expected mean, we have to multiply the probabilities with x. Okay, so by multiplying the probabilities, this one will be 1 upon 13 and then 5 upon 26. By multiplying 5 upon 26 with this one, these are the values for x. 5 upon 26 into 2, this will be 5 upon, this will result in 5 upon 13. Then by multiplying 4 upon 13 into 3 with 3 will result in 12 upon 13. And the last one, 11 upon 26 with 4. So 2 2s are and 2 13s are 11 to 22 upon 13. Okay, so now the other thing, x square. It's a bit untidy, like you have to make it very clear because you have a space there. I'm focused on the question, so it's a bit untidy, but I hope that it's clear, like you can understand what I'm doing. So now I will take the squares here, like for this one, e and x square. So in this one, what we do, we multiply x square with the probability of x. Okay, so now here x square will be 1 and the probability is 1 upon 13. So for the first one, it's 1 upon 13. And now doing the next one, so 2 to the power of 2 will be 4. So 4 into 5 upon 26 will result in 22 upon 13. And then 3 to the power of this one, 3 to the power of 2 is 9. So 9 into 15 upon 26 is 135 upon 26. I'm doing this on my calculator. So now the last one is 4 to the power of 2 times 11 upon 26, 88 upon 13. I did a mistake here. So this one is, let me correct this one. So this is 10 upon 13. Okay. Yes, and another mistake here, I have the calculation mistake. I did a calculation mistake here. So this one is 36 upon 13. Now I think everything is fine. Okay, so now, so the sum of this is 135 upon 13, and the sum of, let's say, expected mean is 40 upon 13. There you go. So now we'll just put them here. 135 upon 13 minus 40 upon 13 square. Okay, so now we'll solve this. So I got 155 upon 169. So this is the value for, this is the variance. Now I'll put the variance here. So 13 square into the variance. So we know that 13 square is 169, and 169, they will be cancelled with each other, and the answer is 155. So this question is done. We're done with question number 7. Now moving towards the last question. Last question is here. The random variable x is normally distributed with the mean and variance 36, given that p mu minus 2k is less than, like x is greater than, x is in between them. Find the value for k. So now if I make the bell-shaped curve, this is mu, and let's suppose like on this is the positive side, where we will add, like we add the standard deviations. So what will be the standard deviation? The standard deviation, the variance is 36, so the standard deviation will be 6. Like 36 equals to 6. 6 will be the standard deviation. 6 will be the standard deviation. Okay, so now this side is, this is mu plus 2k according to the question, and this is mu minus 2k, and this portion is 0.6 as they claimed in the question. So symmetrically, like I have as this is a symmetrical shape, so both the sides, like both are same here, so it means that this will be, this and this, both of them will be like the total probability is 1. So after subtracting 0.6 from 1, we get 0.4, which means that this portion will be 0.2 and this will also be 0.2. It's equally distributed. Okay, so now which means that if I go on this side, if I go like as the table z-score suggests, like we can find the values on the left side and the positive values. So if I go on this side, the total area on this side, the total probability on this side is 0.8, which means I can write it like this, like probability of, this is the population, and it's less than mu plus 2k, converting this into z-score. So this will be mu plus 2k minus the mean upon the standard deviation, which is 6 here, equals to the area. So the area on this side is 0.8. Now we have a z-score, this is the z-score, so now we will also calculate z-score for this probability, for this area. So the z-score for this area will be like going to the calculator. Okay, so menu 7 inverse, the area is 0.8416. 0.8416 is the area. 0.8416 times 6 will go there and cancel, they will be cancelled with each other. So 2k equals to, let me calculate this by the calculator. 0.8416 into 6 divided by 2, so I got k equals to 2.5248. This is the answer. Okay, so now moving towards the next part. So the next part is, I already have the value for this. Let me clear this. Hold on. Probability is given here. The random variable y, the second part, the random variable y is normally distributed with mean mu and standard deviation, given that 2 mu is equal to 3 times variance, and then this is given here. So now we will use this one because the probability is given here, and we need to find the mu and the standard deviation, the value for the standard deviation. So we'll convert this into z-score, so it will be z greater than 3 upon 2 mu minus mu upon the standard deviation equals to 0.0668. This is the probability, the area. Okay, so now solving this one, let me compare the values. Like I will also like find the z-score for this value from the calculator. 0.0668. Let me go to the z-square. This is the area, 0.0 I guess. What was the value? Hold on. 0.0668 minus 1.5 is the value. And now you can see that this is representing this amount. You can see if I make a bell-shaped curve, so this is a very small amount. So either it will be on this side or it will be on this side, but they are saying like here that it's greater than 3.2 pi. So the greater area can't be 0.6. like if I go for this, like if I chose this portion, so this whole can't be 0.0668, which means that this lies here. So I will use a positive value for this. Like this portion in terms of z-score, this is a positive side and this is a negative side. So I will write it here, 1.5 in terms of z-square, it's 1.5. And now solving this one now, converting like the standard deviation will go to the other side, and now simplifying this one, so this will be 1.5 minus 1 will be 0.5 mu. Now we got two equations here. First one was given in the question and I just arranged it here. This was the first equation, and this is the second equation which I got. Now I will make, like already mu is subject here, I made it here. Now I'll replace it using the substitution method in this equation. 3 upon 2 variance equals to 1.5, that's one, and I'll cancel them. So 0.5 upon 1, sorry. So standard deviation will be here, so changing the sides upon 0.5. Now putting this in the calculator, 1s are 2s are 2 1s are 2 1s are, and 1 upon 0.5 is 2. So this is the answer for the standard deviation. Now finding the value for the mean, 2 square. So this will be 6 is the answer for the mean. I hope it's clear. This question is clear. The paper is done. Thank you very much.